In this video, I would like to talk about passing parameters to functions by value versus by reference, how to pass parameters by reference, and why you might want to do so. So let's take a look at this example code here. I have main, and within main, I declare an integer variable var, and I initialize it with 5. Then I call print value function, and I pass var to it, and when I return, I print var. Now here's the print value function. It accepts integer param and returns nothing, that's void. And all what it does, it basically prints param and then changes it to 10. Now to understand how parameters are passed, let's trace this code as it executes. Now when we declare the variable var, it gets allocated somewhere in memory, let's say here, and the initial value is just 5. Then when we call this function print value, we jump here. The parameters for this function are allocated, and I have only one parameter, and let's say it was allocated here, so that's param. Now as an initial value for param, we get a copy of the variable that was passed to it, and the variable that was passed to this function is var. It has the value 5, so it gets copied here, 5. Now from this point on, these variables are completely separate. So this is called call by value because we're just copying the value here. So what happens when we get into this function print param, so it's going to print 5, and then changes param to 10. So this one is going to be changed to 10. Now because these are completely separate, this change does not affect this variable. So when we come back from this function call, we try to print var is still 5. So let's go ahead and compile and execute our code to verify that this is exactly what's happening. So g++ main.cpp -o main, and now let's just go ahead and execute this code. So we expect param to be 5 and var to be 5 as well. So there you go, param 5 and var is 5. Now alternatively, we can call this function by reference, and in order to do that, we only need to make this a reference. And to make this a reference, we just add the ampersand sign here, and this makes it call by reference. Now let's trace this code once more with this change. Now just like before, var gets allocated somewhere in memory, and it gets the value 5. And then we have a function call, so we jump here. Now param is labeled as a reference. So a reference is just an alias or another name for the variable that was passed. So we don't have a complete separate location here in memory. All what happens is that the same location is kind of labeled with another name, so param. Now we get inside, param is printed, prints the value 5, and then param is changed to 10. So this is going to be now changed to 10. But remember, param is just the same as var. It's just another name for var. So var has been changed to 10 now. So when we return, print var is going to be 10. So that's called by reference. When I call a variable by reference and the function makes a change to that variable, the change is reflected on the caller. So let's see this is happening when we compile our code and run it again. So main.cpp -o main, and now let's run it, and as you see we get 5 and 10. So 5 here, and when we return, the change that happened within the print value function did reflect on var, because param and var are basically two names for the same variable. Now obviously one reason I might need to pass a parameter by reference is when I need to preserve a change. So take an example where I'm creating a function to swap two variables, right? So I'd like to have two variables in main and then call the function to swap them for me. So obviously I need these values to be swapped when I return from this function. So let's just write it as call by value and see if that's going to happen. So we'll create a function called swap, and we're going to pass two parameters, x and y. And we're going to swap these variables within this function. So in order to do that, let's create a temporary variable and then initialize it with x, and then x equals y, and then y equals temp. So this is going to swap the two variables. Now let me create these variables here. So I'll just say var1 equals 5 and var2 equals 10, right? And what I'm trying to do here is basically swap these variables, and when I return, I would like to print the variables to make sure that they're swapped, right? So I'll do swap, and I'll pass var1 and var2. Now what I'm hoping to see is that when I return, var1 would be 10 and var2 would be 5. But I know that's not going to happen because I'm doing code by value, right? So, but let's just verify that. So this is var2. Now if I just go ahead and compile this and then run it, now as you can see, var1 is still 5 and var2 is still 10, because the change that happens within this function is not going to be preserved when I return. If I want that change to be preserved, I'm going to be passing these by reference. Now if I do this and compile again, and then just run it again. Now as you can see, the variables were actually swapped. var1 is now 10, var2 is 5. Now this is a very good reason why I might need to use code by reference. Another very good reason for passing parameters by reference is if the parameter is a very large object. Now passing large objects by value involves copying these values or these objects, and copying consumes computer resources and slows down my program. To demonstrate this, let's go back to the original example and pretend that var is a very large object. Now because I'm accepting parameter by reference, no copy is involved, and this is a very fast function call. But let's assume that print value isn't supposed to change the parameter. I'm only passing this for the purpose of improving performance. And if this function happens to change this parameter, then this is going to break the code after the function call, because in main, I'm assuming that this is not going to change var. Now the problem is that few months down the road, I may forget this fact and go ahead and change this parameter, and therefore break the code after the function call. So to prevent this, I can explicitly label this as a constant. Now when I label it as a constant reference, as you can see, immediately this gives me an error. Because it's a constant, this function cannot change this parameter, and I get the best of both worlds. I pass the parameter without a copy, and I ensure that this function does not change this parameter, and therefore it does not break the code after the function call. Now, one last thing I want to say about code by reference and code by value is that I can have some parameters being called by reference and others being called by value. So for example, I can have another parameter here that is called by value, and therefore it has a copy. It's not like all the parameters need to be by value or by reference. I can mix and match the way I want. So that's it for call by value versus call by reference, and I'll see you in the next video.